In part 2 of our seminar, we're going to look at probability of area. And just like length, it's pretty much the same thing. Our sample space would be the entire area, and what we want to find, the favorable outcome, would be the area we want to be in. Now, if we take a look at example 3, it says the targets of 3 dartbirds are formed by 3 concentric circles. So I think what we'll do to start with, let's model this. Let's draw a picture. We're going to make 3 concentric circles. I didn't make them very concentric there, did I? Okay. And it says that the diameter of the center circle is 4 inches. So let's label that as 4 inches. And then we know they're spread 3 inches apart. And so I want to know what's the probability a player will throw into the center circle. Let's find the area of our center circle. So the area of our center circle is going to be pi times r squared. Didn't write my pi there. Let me redo that and put the pi in there. And notice my diameter is 4, so that means my radius is 2. So it'll be pi times 2 squared, or 4 pi. That's my favorable outcome. The area of is my favorable outcome. Now let's do our sample space. And it's also a circle. And I think your first 2 questions are pretty much like this on your assignment. Now, we got to find the radius of the big circle. Well, we know the radius of my center circle is 2. Let me write that in there. If I add 3 onto that, I'm going to get 5. If I add 3 onto that, the radius of my center circle is going to be, why did I say 8? That's dumb. 3 plus 3. 3 plus 3 is not 8. Sorry, that's 6. Wow. Let's back that up. I apologize. Let's try that again. 2 plus 3 is 5. And then 5 plus 3 is 8. I had 8 the first time. I just wrote it down wrong. Okay, so the radius of my sample space is 8. So we're going to say pi times 8 squared, which is going to be 64 pi. Then I'm going to find the area, or the probability, of being in the center. Well, that's going to be 4 pi over 64 pi. Notice I left my pi's out because they reduce. And I get 1 to 16. 1 to 16 is kind of hard to understand. So I'm going to change that to a decimal. So that's about 0.06 or 16%. Now, is it truly 16%? I would argue it's not. Okay? This is mathematically true. Because what we're saying mathematically is when I launching darts, they have an equal opportunity of landing any place in my circle. But a dart player doesn't throw random. They want to be in the center. So the better skilled you are, the higher probability that you would hit the center circle. So mathematically, it's 16. Why is it 16%? Wow, that is embarrassing. It's 6%. Mathematically, it's 6%. I think I copied down the 16 in the denominator instead of the 6. Why aren't you writing? There we go. So mathematically, it's 6%. But in reality, it'd be much higher than that if you're skilled. 6% would be pretty much only if you took your 4-year-old brother or sister and had them just randomly throw a dart at a dartboard. Okay, now, also with area, we have angles. And I like the angles because to me that just makes common sense. I want to find the probability of landing in region 3. Notice that's 122 degrees of the circle. So it's 122 out of 360. And then I just want to reduce 122 over 360. In fact, I don't think I'm going to do that. I'm just going to write that as a decimal, 0.34 or 34%. And then if I look at region 1, well, region 1 is 26 degrees. Probably don't even need to do a region 1. I won't do that in class most likely. So it's 26 out of 360. And if we take 26 divided by 360, we get about 7%. 0.07 or 7% on our calculator. And obviously, I could reduce those and still be right. In fact, we'll do that together. So 26 over 360. And if I reduce that, I get 13 because 2 goes into both of them. 13 over 188. And the reason I went straight to a decimal is that doesn't make intuitive sense when the numbers are that big. If I take 122 and I divide it by 360, I get that divided by 2 is 61 over 180. What did I say? 188. 180 on example 4. Full of mistakes when I'm making this video. And 61 over 180. Since it's 180, you can kind of intuitively see that because 180 we know is a straight line, so I could think about 61 over 180, but I like the decimal much better.